Part A, find the average rate of change of the area of a circle with respect to its radius, r, as r changes from the following: 2 to 3, 2 to 2.5, and then 2 to 2.1. Okay, so the first thing we need to do is we need to talk about what is the formula for the area of a circle. We know that the area of a circle, which we can say is a of r, that is the function, is equal to pi r squared. Okay, and now we want to, if we're talking about the average rate of change, okay, recall that when we talk about the average rate of change, we're talking about the slope. So remember that the slope is y2 minus y1 over x2 minus x1. Okay, and so what we want to do is we want to find out what is the average rate of change when it comes to the radius. So what we're looking at is, okay, well, we want to find out what is a of r2 minus a of radius 1 divided by radius 2 minus radius 1. Okay, so that's the average rate of change when we're dealing with the circle. Okay, so if we want to find out from 2 to 3, that means you want to find what is a of 3 minus a of 2 divided by 3 minus 2. Okay, so if we plug in r, so that means we're going to have pi times 3 squared minus pi times 2 squared over 3 minus 2, which is 1. So we end up getting 9 pi minus 4 pi, which over 1, which is equal to 5 pi. So we got the 2 to 3, there's the average rate of change, which is 5 pi. Okay, now we're going to go from 2 to 2.5. Okay, so by doing that, again, we want to find out what is the average rate of change. So it's a of 2.5 minus a of 2 divided by 2.5 minus 2. So we end up getting pi times 2.5 squared minus pi times 2 squared all over 2.5 minus 2, which is 0.5. So we end up getting 6.25 pi minus 4 pi divided by 0.5, which is equal to 4.5 pi. Okay. So next is 2 to 2.1. So going from 2 to 2.1. So we want to find a of 2.1 minus a of 2 divided by 2.1 minus 2. So that's pi times 2.1 squared minus pi times 2 squared divided by 0.1. And so we would get 4.41 pi minus 4 pi over 0.1, which gives us 4.1 pi. So I want you to notice here that we're going from 5 pi to 4.5 pi to 4.1. So it's getting smaller and smaller as the increments get smaller and smaller according to part A. Now for part B, they want us to find the instantaneous rate of change for when the radius is equal to 2. Okay, so the instantaneous rate of change means that we need to find the derivative of the function for the area of a circle. So a of r, which is equal to pi r squared, what we want to do is we want to find a prime of r. So what is the derivative of pi r squared? Well, that becomes 2 pi r. So therefore that is the derivative. And now we want to find out what is the instantaneous rate of change for when r is equal to 2. So we want to find a prime of 2. So that's 2 times pi times 2, which is equal to 4 pi. And so therefore there is our result for part B. Now for part C, it's asking us to show that the rate of change of the area of a circle with respect to its radius at any r is equal to the circumference of the circle. Try to explain geometrically why this is true by drawing a circle whose radius is increased by an amount of the change of r. How can you approximate the resulting change in area, change in A, if the change in r is small? Okay, so the first thing that we need to look at is that we know that the derivative of the area of a circle gave us 2 pi r. Okay, which is equivalent to what of a circle? Well, it's equivalent to the circumference of a circle because the circumference is also equal to 2 pi r. So let's take a look at a picture. So if we have a circle, let's go ahead and create a circle here. All right, so now we know that a circle has a radius of r. Okay, and so then if we create another circle, okay, using the same center here. So now we're going to increase that circle, okay, to make it bigger there. And so what does that tell us? Well, that tells us that we have now a new radius. And that radius is going to be r plus, since this represents the change in r, so this is r plus the change of r. So now what we're going to do is we want to determine, okay, what's happening with the area of the new and what's the area of the old. So we know that the area of the new, which is going to equal pi times the radius squared. Well, the radius is r plus the change in r squared. And then we know that the area of the old is equal to pi r squared. So what we want to do is we want to find the change in the area, and the change in the area is taking the area of the new and subtracting the area of the old. And so the area of the new is pi times r plus the change in r squared minus pi r squared. Okay, so we need to expand this, so therefore this is going to be pi times r squared plus 2r times the change in r, plus we have the change in r squared, and that's minus pi r squared. So the next thing we want to do is we have pi r squared plus 2 pi r times the change in r plus pi times the change in r squared minus pi r squared. And so we can see from here that we can eliminate the pi r squareds. And then what's left? Well, what's left is we can factor out what they have in common. Well, we can factor out a pi, and we can also factor out a change in r. So what's left is 2r plus the change in r. So that represents the change in A, or the area. So now we want to find the change in the area over the change in the radius. So we found what the change in A is, which is pi times the change in r times 2r plus the change in r divided by the change in r. So we can then simplify the change in r, and what we end up getting is pi times 2r plus the change in r. And if we distribute that, we get 2 pi r plus 2 plus, okay, let me write that again, 2 pi r plus pi times the change in r. So we can see here that this is a small amount, and because that is a small amount, then we can see that we end up getting the formula for the circumference of the circle, which is 2 pi r.